So perimeter and area of similar figures. The first thing I want to do is just a quick example. So we said that similar polygons have the same shape but different sizes. So if I draw two similar rectangles, 2 to 3, 2 by 3, and 4 by 6, we know that those are similar because they have the same ratio of their dimensions. However, they're different sizes, clearly. The ratio of the... So we're going to set three ratios up for this section. The first one we want to do is the ratio of corresponding sides. Ratio of the corresponding sides. The next one is going to be the ratio of the perimeters. The ratio of the perimeters. And the last one is the ratio of the areas. So ratio of the corresponding sides, the ratio of the perimeters, and then the ratio of the areas. What does corresponding mean again? If I say the corresponding sides, what does that mean? What does that mean if they're corresponding sides? Naomi? Yeah, so which one would match up with the 3? 6. Do you guys want to do 3 and 6 or 2 and 4? 2 and 4. So the ratio of the corresponding sides would be 2 to 4. We're going to do the small one first. Doesn't matter which one you put on top. All that matters is that you keep the same order. So if I'm doing small on top, then it has to stay on top. The other way we could also write this, of course, is 2 to 4 like that. Right? When you're given these problems, always reduce. 2 to 4 reduces to 1/2. So the ratio of my corresponding sides is 1/2. Right? The ratio of my perimeters. The ratio of my perimeters. Well, this is going to be a 2, this will be a 3. This will be a 4, this will be a 6. So my perimeter for this one is going to be what? 10. And my perimeter for the green is going to be 20. So the ratio of my perimeters is going to be 10 over 20, which reduces to 1/2. Okay, 1/2. The last thing we need to do is the ratio of the areas. My area for the red triangle or red rectangle is what? 6. 2 times 3. The area for my green is 24. And of course I'm dropping the units here, but it would be units squared. So if I look at my ratio of the areas, I get a 6 over 24. What does that reduce to? 1/4. What I want you to notice, the ratio of the corresponding sides is equal to the ratio of the perimeters. However, the ratio of the areas is not equal. Right? We're going to do one more problem, and hopefully it will become a little more clear. This time I want you to do a 2, 3 again, a 2 by 3. But instead of a 4 by 6, I want it more generally. I want to scale it by a factor of t. So to scale by a factor of t, I need to multiply both sides by t. So this will be 2t, and this will be 3t. 2t and 3t. It's exactly like we did the last problem, except now instead of multiplying by 2, I'm multiplying by any number, t. Okay? Once again, I want the corresponding sides. Corresponding sides, I want the perimeter, and I want the area. Corresponding sides, perimeter, and then area. Do you want to do the 2 or the 3? 3 this time? So corresponding sides is going to be 3 to what? 3t. Now, in this case, the 3's will cancel, because you get a 3 divided by a 3. 3 divided by 3 leaves you a 1, so you get 1 over t as your ratio. All right? 1 over t. The perimeter, what's my perimeter here? Same as last time, my perimeter is 10. What's my perimeter here? 10t. Because I get 2t plus 3t will be 5t, and then you just double it for the other two, and I get 10t. So my perimeter is going to be 10 over 10t. What happens with the 10? Cancels. So the ratio of my perimeter is 1 over t. Once again, notice that they're equal. The corresponding sides and the perimeter have the same ratio. However, when we got to the area, it wasn't equal before. What's my area for the first one going to be? What's my area for the second one? 6t squared, because I have a t times t becomes t squared. So I get 6 over 6t squared. What happens with the 6's? Cancel. We get 1 over t squared. Right? 1 over t squared. If you look back at the problem before, 1 over 2, what's 1 squared? 1 still. What's 2 squared? 4. Okay? Exactly.
Wait.
Oh, sorry. So Monica, just could you say it again?
I said that the area is going to be the squared ratio of the perimeter.
Exactly. So the ratio of the areas is going to be the square of the ratio of the perimeters, which makes sense if you think about your units. If I said, what is the perimeter of a shape, you would say 10 inches or whatever. If I said the area, you would say 10 inches squared, right? So it's not hard to remember. If it's the area, it's always going to be squared. So as she said, if two polygons are similar and have a ratio of A to B, this should be a side ratio. If they have a side ratio, so their sides are A to B, then the ratio of their areas has to be what? Squared. So what would this be?
A squared.
Yeah, or I'm going to put colon here. A squared to B squared. So, sides is going to be A to B. Perimeter is going to be the same, A to B. Area is going to be squared, so it'll be A squared plus, not A squared plus, A squared to B squared. Although we're not going to talk about it in this chapter, anybody want to guess what the volume would be? Yeah, cube. It would be A cubed to B cubed. Because volume you would measure in, if I said what is the volume of this box, you would say, 120 inches cubed. Same thing with your, notice how the squares work that way, and then the cubes for the volume. You ready?
No.
Kevin? So A squared to B squared. When we solve problems with these, you'll find that this section should be fairly simple. The homework will be fairly simple, I hope. The triangles are similar. Find the ratio of the perimeters and the ratio of the areas. Simple enough. You guys are fine with these, I think. perimeters, I want red to blue, so we write which one first? Which one? Red. So what's my ratio of the perimeters going to be? Remember that the ratio of my perimeters is equal to the ratio of my sides. So all you need to do is find the corresponding sides. Well, there's only two numbers given. So it's got to be 8 to what? Reduce it. 2 to 3. So the ratio of my perimeters is 2 to 3. Therefore, the ratio of my areas has to be 2 to 3 squared. So it's going to be 2 squared to 3 squared, which is 4 to 9. Right? In the area, remember, you have to square the ratio of your perimeter.
Would you like us to do the double step or just skip that?
If it's real easy, you can skip it. Alright, so like 2 to 3, you can skip it. I just want to show you where those came from. Alright? Can I move on? Next problem. Somebody read that for me, please? Jose?
A large rectangle baking pan is 15 inches long and 10 inches wide. A smaller pan is similar to the larger pan. The area of the smaller pan is 96 square inches. Find the width of the smaller pan.
Alright. Where should I start? Sarah? Draw them. So I have a large one. What are my dimensions on the large one? 15 inches by 10 inches. What else should I draw, Sarah? Smaller one. Got to be similar, so it has to look the same. What do I know about the small one? The area. So I can say the area is equal to 96 inches squared. Okay? How could I solve this one? Any thoughts on how I could solve this one? Kimber?
The ratios of the area. Did you find the area of the larger one?
Sure. So we know, she says, we know the area of the small one, so let's find the area of the large one. So the area of the large one would be what? 150 inches squared. All right. So we got 150 inches squared. What should I do now? I'm sorry? Set a ratio, does it matter which one that goes first? As long as you are... I'm sorry, I can't hear you.
As long as you keep the same ratio for the ratio of the perimeter and corresponding size.
Sure, so as long as you're consistent. Okay? Which one do you want to do on top? So 150 over 96. Are we okay with this so far? What do I need to do? Reduce it. What goes into both of those? 2, sure. So we get 75 over 58. No, not this. All right, 48. And then 3 goes into both of those. So we get 25 over 16. Anything go into both of those? No. Was this the ratio of the perimeter or the area? So this is the area. How do I move from the area to the perimeter? Find the square root. Remember, perimeter to area, we squared them both? Now we're going backwards. So to find the perimeter, we take the square root of both of them. So my perimeter, please. What would my perimeter be, please? Brenda?
4 and 5.
Which one's on top?
5.
So it's 5 over 4 for my ratio of the perimeters.
Yeah.
At this point now we can just set up a proportion. So we know that 5 over 4, big to small, is equal to, what does it want? The width or the length? Which one's length? The longer one or the shorter one? sorry, the length is the longer one. So this would be my length. My width is my shorter one. So 5 over 4, big to small, is equal to, I want to find the width of the small one, so W. What's the other number I need to plug in? 10. We went big to small for the perimeters. And remember, the perimeter is the same as the corresponding sides, right? So the corresponding sides, we know that the corresponding sides also has to be 5/4. So if I do 5 to 4, big to small, I want to find the W. Well, what's the corresponding side to the W? The 10. Okay? Does that make sense why I plugged in the 10 now? And then how do I solve a proportion like this, Brenda?
Why is it a W not a 15?
Why is it W not a 15? Because we were going from the big rectangle to the small rectangle. There is no 15 on the small rectangle. We want to find out the width, so we chose the corresponding sides. So we chose the two sides that match up together. We know that from the big to the small is 5 to 4. Are you okay with that part?
Yeah.
Because the perimeter is the same as the corresponding side. So I plugged in what I wanted to find, which is the W. That's the small one, so it goes in the denominator. We know that it's 5 to 4. And then the last piece is what number matches up with the W from the big triangle, because it's in the numerator, or the big rectangle? Well, that has to be the 10. Helpful or no? Okay. And then how do I solve the proportion? Cross multiply. So I get 5W equals 4 times 10?
44.
So W equals
8.
8 inches. Alright? 8 inches. You could easily check this. So if 10 is 8 inches, we know that 8 times something equals 96. What is that going to be? 12? So we know the length has to be 12 inches. Notice that the proportions hold true. 15 over 12 is the same as 5 over 4. Those are equivalent. Okay, Carlos? Over here? Which part? The solving or the setting it up? Guys, please. Setting it up. We know that the area is this. You okay with that? We take the square root to find the perimeter. We know that the ratio of the perimeter is equal to the ratio of each individual side. You okay with that so far? Big to small. You cool with that? So big to small, 5 over 4, equals. What do we want to find? We want to find the width of the smaller pan. So that's W. And I plug it in the denominator because the small pan went on the bottom. Okay?
5 to 4 is the ratio of the big rectangle.
5 to 4 is the ratio of the sides, which we found down here. Right here. So we found this first going across this way.
Which rectangle? Big or small?
Which rectangle what?
5 to 4 is the ratio of the big rectangle.
It's the ratio of both. The big one to the small one, 5 to 4. You okay with solving the proportion, Carlos? Okay. Alright, the last one we're going to do, find the area of the red polygon. Find the area of the red polygon. What ratio can I set up easily? The ratio of what? So my options are sides, perimeter, or area. Sides, I have 2. Do I have 2 for the area, though? No. So area wouldn't work. I need to use set up the perimeter of the sides. So the perimeter of my sides is what to what? 15 to 20. Can we reduce that? To what? 3 to 4. then I know that the ratio of my perimeter is equal to the ratio of my sides. So that would also be, and then how do I get to my area? Square it. So it becomes 9 to 16. Quran?
When you reduce it to half, can you,
To 3/4, you mean?
no, like when you was giving the first one, like you reduce 2/4 to 1/2, does that, leave it as a fraction or can you put it in the
Either way, they're just both ways to express ratios, whatever you prefer. Okay. So we know that the area ratio is 9 to 16, and now we just need to set up a proportion. So for my proportion, I know that it's 9 over 16. This again is red to blue in this case, small to big, equals, where am I going to plug in this area? Where am I going to plug in that area? Why the bottom? Yeah, because we put the big one on the bottom to begin with. So this is 240. What should I put on the top? X. What does X stand for? The area of the red polygon. How do I solve? Cross multiply. So I get 16x equals, I don't know what that is. 160. And then we divide both sides by 16. Guys, quiet please. And x equals 135 centimeters squared. So just to recap, you can find the ratio of the perimeters, you can find the ratio of the sides. Those are always going to be, ratio of the perimeters and the ratio of the sides will always be the same. The ratio of the area, what do you need to do? You have to square it, okay? The last step then is to set up a proportion and solve for whatever piece is missing, okay? Make sure that if you're solving for the area, you use the area ratio. If you're solving for a side, make sure you use the side ratio. Carlos?
So all the ratios pertain to both shapes, right?
Because we're setting them up from one shape to the other, yes. Okay. Previously, we've done ratios within a shape. For this section, we're always going to go from one shape to the other one. Yep.
Why did you go to
Because remember, the perimeter, we have to square it to get the area. So 3 squared is 4 squared. If you forget, remember area is always like units squared. So whatever it is for the perimeter, you need to square it in order to get the new ratio. All right? I want to give you your homework, and then I want to go through the problem that I gave you on Friday. All right? So your homework is right there. Oh, come on, Michael. Stops. Your homework is up there. It's very short. If you have any questions, please come see me promptly after school. We do have a faculty meeting today. So please see me promptly after school if you have any questions. If you need to borrow a calculator or something, come see me. If you are, one second. If you are spending, wait, I don't want to, I got to go over the problem. I'm not going to give you time, sorry. If you have any problems with it, please come see me. You should not spend more than 15 minutes on this homework. All right?
Are you what?
The textbook is no longer available online.
No, it hasn't been available for a while. Really? I know. So did everybody else. And then I made several announcements about how it's not available anymore.
But only chapter 10 and up.
Correct. Alright, what do I want to go over?
I think